right, let's talk about India's climate. It's this incredible, complex system, almost like a masterpiece, really. It's shaped by these absolutely massive mountains, huge oceans, and some pretty powerful forces you can't even see. We're going to get into all of it. So here's the big question, right? How is it possible that one part of India gets hit with these devastating floods year after year, while another part is literally one of the driest places on Earth? I mean, we're talking about a place that gets over 1,000 centimeters of rain versus a place that gets less than 10. It seems impossible. Well, stick around because we're about to figure out exactly how that works. Okay, so here's our game plan. We'll start with the basics, weather versus climate. Then we'll give India's climate its proper name. After that, we'll look at the giant mountains that act like walls and rain catchers. Then we'll get into the engine that powers the whole monsoon. And finally, we'll zoom out and see how this all connects to the rest of the planet. Let's dive in. All right, first things first. Before we can really tackle the monsoon, we got to get our definitions straight. You hear people use the words weather and climate all the time, sometimes like they're the same thing. But trust me, they're totally different. Here's a super simple way to think about it. Weather, that's your mood for the day. You know, 1 hour you're happy and sunny, the next you're a bit stormy. It changes fast. But climate? That's your personality. It's the big picture, the consistent pattern of who you are over, say, 30 years. And it's India's climate personality that we're really going to get to know today. So, speaking of personality, what is India's climate identity? If you had to slap one label on it, what would you call it? Well, lucky for us, there's a name that fits perfectly. And here it is, a tropical monsoon climate. That's the one. Now, the tropical part is pretty straightforward. It just means it's pretty warm all year. But the monsoon part, that is the star of the show. It's all about winds that completely reverse direction with the seasons. And this reversal is what brings those famous wet and dry seasons. This isn't just a weather pattern. It's the very heartbeat of the subcontinent, you know? It dictates everything for more than 1 billion people. Okay, now for what I think is one of the coolest parts. We're going to see how giant, physical things, I'm talking mountains, can literally control the climate for an entire subcontinent. It's a perfect example of how in India, geography is pretty much destiny. And when you talk about barriers, there is nothing, and I mean nothing, bigger than the Himalayas. They're not just some mountains. They're basically India's climate control system. So check this out. The Himalayas play two incredible roles. First, they're like a giant wall, protecting India from those icy cold winds that sweep down from Siberia. That's why northern India doesn't turn into a frozen tundra in the winter. But at the same time, they act like a huge catcher's mitt. They trap all that moisture-filled monsoon air coming up from the ocean and basically squeeze all the rain out of it. This is what feeds the rivers and makes the plains so fertile. All right, let's head south and west to another mountain range, the Western Ghats. They run right down India's west coast, and they pull off a similar kind of climate shaping trick, just on a slightly smaller scale. And this creates what's called a rain shadow effect. It's classic. So you've got the side facing the windward side where Mumbai is. The monsoon winds, full of moisture from the ocean, slam right into it. The mountains force that air up, it cools down, and boom, it dumps torrential rain. But what about the other side, the leeward side, where Pune is? By the time that air makes it over the mountains, it's bone dry. It's already dropped all its rain. So it creates this dry shadow. And that's exactly why you see flooding in Mumbai, while Pune, which is not that far away, is way, way drier. And if you want to see just how extreme this gets, just look at this chart. It's mind-blowing. On one side, you have Jaisalmer in Rajasthan. It gets a tiny 9 centimeters of rain a year. 9. And on the total opposite end of the spectrum, you have Mawsynram in Meghalaya. It gets, wait for it, over 1,100 centimeters. That is just a staggering amount of water. It's literally one of the wettest places on the entire planet, all because of geography. Okay, so we've seen the mountains, the big physical things that shape the rain. But what's the actual engine driving all this? What's the invisible force that pushes those winds in the first place? Let's go behind the scenes, into the engine room, and figure it out. It all boils down to one simple concept: pressure. See, nature absolutely hates imbalance. So air will always, and I mean always, move from a place with high pressure to a place with low pressure. It's just trying to even things out. And that movement of air, that's what we call wind. It's that simple. And I love this little analogy to help you remember it. Think about exam pressure, right? When everything is pressing down on you, that's high pressure. It's like cool air sinking down. Now think about the feeling after the exam's over, when that pressure is released and you feel lighter. That's low pressure. It's like warm air rising up. The entire monsoon system, it's all driven by this one basic idea. So here's how it works in the summer. The huge Indian landmass just bakes in the sun, right? It gets super hot, creating this giant zone of low pressure. Meanwhile, the Indian Ocean around it stays much cooler, which means it's a high pressure zone. So what does nature do? It tries to balance it out. Wind starts rushing from the high pressure ocean to the low pressure land. And on its way, it picks up tons and tons of moisture from the water, and bam! You've got the southwest summer monsoon, carrying all that rain to a very thirsty subcontinent. But hang on! You might be wondering, why do the winds come from the southwest? Why not just straight from the south? The answer is, the Earth is spinning. This rotation creates an effect called a Coriolis effect. And what it does, according to Farrell's law, is it deflects moving things, like wind, to the right in the northern hemisphere. So that wind heading north from the ocean gets a little nudge to the right, giving it that classic southwest to northeast curve that slams right into India. Okay, for our last piece of the puzzle, we have to zoom way out. Because India's monsoon isn't just a local thing. It's actually connected to huge climate patterns that are happening on the other side of the world. Just take a look at this. It turns out that what's happening with the water temperature in the Pacific Ocean all the way over by Peru can make or break India's monsoon. In a normal year, the water there is cool, which helps keep the global pressure systems in balance for a good monsoon. But then you get an El Niño year. That water off Peru gets warmer than usual and it messes everything up. The pressure flips and suddenly India's monsoon gets weaker, sometimes causing serious droughts. And then there's the opposite, La Niña, when the water gets extra cool. That can actually supercharge the monsoon and lead to major floods. It's just a wild example of how connected everything is on this planet. So this all leaves us with a really important question, doesn't it? We've just seen how India's climate is this incredibly intricate dance between giant mountains, simple pressure differences, and even ocean temperatures halfway around the globe. It's a delicate balance. So as global temperatures keep rising, you have to ask, how are we changing that balance? What does the future look like for the monsoon, which is literally the lifeblood for over 1 billion people? Definitely something to think about.